Okay, so my name is Andreas Kazmierczak, and you can see here my name in the on my video, and I am a developer of the program Print2CAD. And as you can hear, I'm not a native American. I'm born in Germany, and I'm speaking as native language German language. My other native language is Polish. I speak both languages, and I will try to speak English very slow so that you understand what I say. And today I will speaking about PDF to CAD conversion, and I will show you how you use our PDF to CAD converter for scanned drawing. Like you put something on the scan and you try to convert. I think we have Frank. Hello, Frank. Hello. Welcome in our group. You can every time send me now a question. I can see here on the left screen what you write me. Steve sent me hello. Hello, Steve. And this is live, and every time I can answer your questions during the webinar. Good. This program is a program made by me. So why? Of course, I have few developers. We are a German company with over 25 years experiences in software developing. This company in USA, we own 10 years long. So like 10 years long, we offer our software on a US market. And in US market, we will offer our conversion software Print2CAD. But what we offer too is our own CAD system. This is what a main product from Germany, what we sell in Germany really a lot. And this is a CAD system made for not only for working station, made for the cloud. Like if you want to use now your CAD system on the cloud, you will not able to install AutoCAD or another system because CAD systems are made only for hardware, for your local hardware, and then you can upload our program and use it, and you work with your CAD system. But what I show you today is how you can use our Print2CAD for our data transfer. And I see we have Paul. Hello, Paul. We have another guy on. Hello, Paul. Welcome in our webinar. Okay, good. So what I'm doing, I start now a very simple conversion. I take here very simple file. This is this file, and let me view this file. Okay, this is a typical PDF file. And if you choose here the file in our converter, first we start the converter here in our Print2CAD, then we choose the file, and now with view input, you can start the file in our internal viewer. Our internal viewer is made for construction drawings. And this is a viewer with very, very interesting features. One very interesting feature is, for example, the possibility to separate on a screen the main PDF entities. If you work with your CAD system, you have a lot of different elements. The name of this element is CAD entity. Like you have circle, wall, dimension, you have leader, you have text, you have multi-line text, etc., etc. But in PDF, you can have only four different elements, because PDF file is not a CAD file. You can have only text, what is named here character. And you see, this is everything. Now, if you push this button, the program separates only a text. And now you see that this is a native text. And to convert this kind of text in CAD is very easy. But look what's happened with this text, and with this text, with this text. If I push this button, this disappears. Why? Because this is not a native text. Let me look, what is it? If you go on image, you can see that this is only a raster image. This text is an image. This. If I zoom it, you can see this frame, this is a border of this image. And here, for example, you can see the table. This is a border of this image too. Like somebody or computer did it, insert in this PDF 1, 2, 3, 4 images, 4 raster pictures. Now, if you go on path, you can see this text is not a native text. This is on a path. In AutoCAD or in another CAD system, the common name for path is polyline. We have another person online. Hello, Lana. Welcome in my webinar. Okay. And what's going on? Why this is not a native text? This is path because somebody used in AutoCAD SHX fonts for this text, and you can't embed SHX into PDF. Adobe never allow it, and this is the reason that if you use SHX fonts, the text have to be exploded into lines. And now this is no more a native text. You see, this is a path. This is the same element like here. What's going on with these circles? See, this is not a circle. This is a polyline. See, looks like a circle. Look, this is a. And now, if you need this circle as a circle, you have to recognize that it was a circle because this is a polyline. And for example, look here. Can you see here this arc? You can see the same. It is not an arc. This is an polyline, and then you need an arc recognition. If you go now here, what's going with this text? This is not a text. This is a field path. What's happened? Look on this text. This is another problem. Somebody was using here fonts. Adobe was not able to embed. And if Adobe is not able to embed fonts, Adobe, then AutoCAD has to put this text as a boundary hedge. What you see, this is only a field path, a boundary hedge. And what is this one? This is a terrible PDF resolution. Like almost every PDF is made in 300 dots per inch in 300 dpi, and you see here you can put all this curve only in 300 dpi raster. And of course, because this raster is orthogonal, you have no problem with the letter F and I, A, T. It looks very similar F to F, but if the text has a curve, you see the problem is there. And now you have to if you need this text as a native text, you have to recognize it. And what the program is doing, the program has a default settings, and these default settings are made for construction drawings, for architectural construction drawings, because the most common use for this program is to convert drawings, construction drawing for buildings, and this is the reason that we use this settings as default. If you need another settings, you can make these settings yourself, or you go on wizard. And here in this wizard, you can take our presettings. So you see, we offer here a lot of presettings. This is, for example, something for CAD drawing. Okay, we write here what is it, yeah, and then you can go maybe here, so, and on next one. And if you see here the picture, what is similar to your picture, okay, for example, this is a bad quality scan. Here is another scan, yeah. Then it's easy. You go on load optimal settings, and then we load optimum. Okay. Or another possibility is what I'm doing now. It'll be I start the program again, and you can modify our default settings using here the functions. We offer here a lot of functions, and believe me, there's no a magic button like convert everything and everything will be okay. The PDF files are so different. They have so many cases of PDF files of drawings that you have to know what you activate. You can use our wizard, but if you don't want to use the wizard, you can activate it. And this is what I will show you in this want to show you now here in this webinar how you can use the settings. So after you view it, if you want to be sure what kind of drawing is it, you can start the analysis. The analysis sorry, I have to choose the drawing again. Sorry, this one. The analysis tell you a lot. Start analysis tell you a lot about this drawing. Now the analysis tell you there are 4 images, 287 separate text, hatch, and path. And these are the 4 possible entities, elements in PDF. No circles, no arcs, nothing. Everything you have to recognize. You can find in a PDF only paths as a Bezier curve. PDF do not contain any circles. Okay, maybe it looks like circle, but it's a Bezier curve, like a special kind of spline. Okay, good. Now, whatever time what you can do, you can use our default settings. Let me start now the program with default settings and let me check what's going on, what is the quality. In this presettings, we will vectorize the raster pictures. And now what I'm doing here, I start now this drawing with our internal viewer. Again, you can, every time we offer not only viewer for PDF, we offer a special viewer for CAD drawings. And this is a very, very interesting viewer. This is not only viewer, it's a simple post-processor tool. And this is not a CAD system. You can't really zoom here something. We don't use a wheel for the zoom because we offer here another functions. If you want to zoom on something, you have to go here and click, and here's everything. Now, why you are not offer this kind of view? Because we offer another functions. These functions are made for the analysis of the structure of this drawing, because now you produce a DWG. You see, this is now DWG. Now you can go on view properties, and now you can see what kind of layers we was able to separate in this drawing. Okay, this drawing was no layers, and we try to separate every element from PDF on a layer depending from color and line weight. Okay, but here's very important view. Now we view this drawing based on entity type. And now you can see here we was able to recognize circles, arcs, here circles, hatches, polyline, line, multi-line text, and solid. Now you can go here on this button localization, and everything will be gray. Now you can see very fast that we was able to recognize this native PDF text as multi-line text. But in default settings, we do not use any optical character recognition for text as line or hatch. You can see this text is still, this is solid, and this text is still a hatch, boundary hatch. Now we can zoom it if you want to see it. And look, the text looks absolutely identical like in PDF drawing. And this is not a text, this is a boundary hatch. Okay, now if you go here on zoom, you can zoom every time. If you scroll it, now we zoom here this part. Okay, let me look at it. This is now entity solid. This is line, and this is polyline. You see, this text is not a native text. This poly is still a polyline. Why? Because again, because the optical character recognition is not activated as default. And why? Because you have to activate optical character recognition with correct parameters. And there are no default parameters for every text. Like we are not able to activate optical character recognition as default, because you have to look at this drawing and you have to activate the correct parameters. And this is why I show you how it works. Okay, for the raster to vector, if you go here again on input, you see we was able to vectorize this table, And we vectorize this table here, the lines we vectorize as a line. And here everything, the small symbol, vectorized as a solid. Why? Because these settings are default settings in our program. If you go here on raster to vector, you can see the vectorization method is center line and outline tracing combination. And we make here for small entities solidization and for very small entities solidization too. Of course, you can switch here to another method. Now it's only center line tracing. This is only outline tracing. A lot of people are using outline tracing for cutting machines or for solidization. This is a method we offer as standard for construction drawing. You see as standard, we can recognize horizontal, vertical lines, 45-degree circle arcs. And now is very important thing. You have to look at the drawing and you can see what kind of text you have to recognize. Because the vertical text is a native text. You don't need to recognize with optical character recognition native text. But here we have a horizontal text, and here we have a horizontal text too. And in images, we have horizontal and vertical text. And now you see we have horizontal and vertical text. And now this is very important that you activate here the optical character recognition with correct parameters. It's very easy. You go here on optical character recognition of a text, and you can start here the automatic optical character recognition. This is what I'm doing now. Now, look, generate text areas, and text slope is 0 degree and 90 degree. And the primary text, the most text, is horizontal. If you have most vertical text, go here. If you have the most text is horizontal, go here. Language is very important. English, United States, because then we are looking, for example, for feet and inch in dimensions. Now, pass, hatch, and raster image. The text is represented by pass, hatch, and raster pair, by everything, but it's 3. If you have text only as raster picture, deactivate it. Then you have better recognition. Resolution 300 dpi is okay. Page number 1. This can stay for everything now. And now okay, and start. And you will see that now the program starts automatic recognition of a text. And this is a very, very, very complicated function. For text recognition in construction drawing, you need a special artificial intelligence methods. Because construction drawing is not a page of a book. On the page of a book, you have text, almost all texts are the same directions. And this is a piece of cake to recognize with optical character recognition text on the page. In construction drawing, you have to look for the text between the construction itself. And if you have a text on the same layer, we are able to find it. But if the text is not on a separate layer, we are not able to find it. If you have PDF with good layers and somebody put your text in PDF on separate layer, then we make a perfect optical character recognition. But in this drawing is everything on one layer. And now the program was able to find maybe 100, 200, 300 texts. And here, now, what is it? In 13 cases, our optical character recognition is not sure that that's what we find is what we recognize. This is only for your control. Look, profile is perfect, good. But here you see the artificial intelligence found this one in your drawing. This is from your drawing, for this drawing, for my drawing. But this is unusual to use this kind of word. And she tell me, the artificial intelligence, it can be more alley. No, I tell her, no, this is correct. And now you have to go here. For example, uplight is a very unusual word. And the artificial intelligence tell, I think it can be upright. No, you can go back and tell me notice is okay. And now you have to go through the full list. For example, what's here happened? Here are circles, but because the circles was on an unusual position, the artificial intelligence think maybe it's as a part of two. If not, then you can go immediately on delete. Also don't use optical character recognition. And it takes maybe a few minutes and you are done with optical character recognition. But look, now we have view the drawing, and now looks what's happened. View properties, entity type, and now you can see text. Everything is text, and this is a multi-line text. And this full editable text, and now we was able to recognize vertical text and horizontal text using artificial intelligence. Now if you zoom here, this detail, you see the text is smooth. Why? Because these are now letters. Of course, my viewer is now, this is a fast viewer moment. I'll check you something. You have every time in background the original letters too. I open this now in CAD system so that you know what's going on. Files open. So now you can edit this text how you want. And every time you have to know that in the background here, you can see we have a spatial layer. This layer is this Print2CAD OCR recognized. This layer is deactivated. If you see in background, every time we put the original. Okay, now we can see what we recognize. So it can compare was the recognition not on. Sometimes if you recognize something bad, you can every time take it from the original drawing. It's not, nothing is deleted, it's only hidden on the spatial layer. Okay, good. It was everything now what I want to show you now here regarding this spatial, this easy drawing. Now we're going to something very, very complicated. Because in most cases, you can see the drawing. Now I take another one drawing. This is the drawing with this number 3. Let me look for this drawing. What is it? Character? Nothing. Image? Everything is one image. Can you see the border here? This is the border of the image. No path, no fill path. What is it? This is not a PDF file. This is normally only a raster picture in a PDF frame. Like somebody put this raster image, somebody scan it, you see in JPEG, it's JPEG, and put this JPEG, it was a dirty piece of paper, you see, put it here and make here a raster picture. And now if you expect that, that our program will recognize the text as a native text, this is really a task for artificial intelligence. I will show you how we do it, okay? If you go on analysis and start it, you can see empty, no path, no hedge, no text. Everything is only one image. And now, the only one thing can you help to make the real drawing. This is the raster to vector and optical character recognition. If you will try to import this kind of drawing in AutoCAD, we ignore it. AutoCAD, we make only raster image, but AutoCAD do not vectorize any raster images and do not make any optical character raster images. We are doing it, and look how it works. First you have look on it and you have decide what is most important here in this drawing. What I want here. And in this drawing, maybe the most important are here the lines for your construction, this geographical information system line, so that you see what is the height here of this. Here you have the height of the points here. This is and now this is topographical information. Here you can tell the topographical informations are the most important. I'm not really interested here in right corners, because this is not so important for me. Just here is a right corner and straight lines. I am more interested here in the curves and in the text, you see. And now, because before you start with separation with raster to vector, we need another very important parameter. The another important parameter is threshold for the color black, because every vectorization is made only in black and white drawing. This is not a black and white drawing. This is a grayscale drawing. And you can go here on color info and pick here one pixel. For example, you can pick this one and tell me this heavy white background. You see, this is a color info. Or you can pick here. You can see I need this point and this one separate. Like here, 0 and 1 have to be separated. So my threshold is this color. And you see the color, it's not a really grayscale, but you see the color is for about 40, 41 hexadecimal. Okay, and this is what I'm doing now. I'm going here to raster to vector, and now I decide what I want to do with this drawing. I decide I need only centerline tracing. I need horizontal and vertical lines, but I don't need any 45-degree lines. But I need arc and circle recognition. I don't have walls in this drawing and deactivated. Chromatic colors to layers is okay. Vectorization too. You need these parameters only if you make a digital photography of something, because you have to contourize it. There are a lot of features for digital photography. This is what I will do next week. Simply, you can go now on video and you will see immediately what kind of parameter. But now I'm doing nothing because it's a scan. It's not a digital photo. Okay. Vectorization 3. This is very important parameter. You see the threshold will be calculated automatic based on statistical methods, but every method made by human mind is better than any statistical method. So I go now on manual determination of optimal threshold and decide that my threshold is about 40 here. Can you see? It can be 39, but very important, it can be less than 40. Okay. Now under vectorization 4, I decide I'm interested in round outlines, curves, and contour lines. And maximal line weighted pixels is okay here. Vectorization 5. I don't want to vectorize to recognize right corners. Small circles okay, but not frames and rectangles. Small cursors okay, small dashes, but I don't have really symmetry there. I don't want to recognize any symmetry because there's no symmetry in this drawing. On this kind, you make the vectorization better. If you activate the symmetry, like in architectural drawings, we have a lot of symmetry. But in this kind of drawing, digital photography or in scans of topographical maps, we don't have any symmetry. Okay, now I have the correct parameters, but I'm doing nothing for optical character recognition. First, let me start it only with raster to vector methods. And you see, look on it and decide what is the most important thing for you. Now, let me view it again in our CAD system. This is full AutoCAD compatible CAD system. You pay for permanent license only $329. Very, very good system. And looks what we did. Now we have here beautiful curves. So like the program gave you the beautiful curves here, but look what's happened here with my text. This is what the program did, exactly what I told. Vectorize everything. Trace in the center of pixel tracing a line. And the program did it. Here the program was able to recognize circles. See? Here the horizontal lines. But this text is not a native text. This is only a center line tracing. Because the program did exactly what I told. Look, raster to vector, center line tracing for the wall drawing. Now I activate again this method. Center line tracing combination and outline combination, and for small pixel traces, like this small symbols here, I use solidization. Let me do it now with these settings. Okay, you will see this is the reason that the settings are all our default settings, because the settings are really perfect for bad quality scans. Because the text looks very similar. If you vectorize this text, it will be not, you can't really read it. Now look what's happened. Can you see it? It looks more like 101.6. We do not vectorize it. Now, of course, you can take it, you can move it, you can do what you want with it, but you have to know that this is only a symbol solid, like you can delete it. But let me ask, what is it? You see, this is a solid, entity solid, very fast quality catch. But what you can do now if you need this text, a native text? Now, this is a very, very complicated task, and our program is really good in this complicated task. And this task name is Artificial Intelligence Optical Character Recognition, because the program has to pick up the text. And you can use two kinds of artificial intelligence text. Full automatic text. My text is only horizontal, and my text is as a raster picture. Language is English, United States, and now you see automatic, 0 degree. I don't have vertical text, primary text, and raster. And let me check it. Now what's going on? Now we start the raster to vector methods and optical character recognition. And now the program has this absolutely difficult task in this bad quality scan to look for possible text and to recognize this text as possible text. Now you see in 3 cases we are in doubt. The program found HF, but it is H he, but we tell no, it is HF here. This is something we don't want it. Let's delete it. Okay, and here the program thinks this is a text, but it's not a text. Delete it. Only 3. The text is in doubt. And now look what the program is doing. Now if you open the drawing, look, you see we was able to recognize this drawing, but look what's happened. This is very interesting. We was able to recognize 1 asterisk 101.6, but we recognize here 111, and looks here we recognize 111.5. Let me check what's going on. Let me look to the original drawing. So here the problem is that this one is connected with this 5, and now the artificial intelligence is not able to recognize that it is 111,5, because this is connected. And this is the reason that it gave you 115. It's too bad quality scan. But let me look here. What's happening with this one? Here I was able to recognize 1 asterisk 101.6, but here we recognize 111. Let me check it. What's happened? because this really looks like 111. For artificial intelligence, this is 111, and she decide, or he, depends who is artificial intelligence, decide that it have to be with 80% probability, 111, and only with 20%, 111. Okay, like this is like a fuzzy logic. Like this logic is not it is, it's like it can be. You understand? And now it's very important thing what you have to know, that you have to change the quality of this fuzzy logic to go to next stage. We have another stage of artificial intelligence here, enhanced optical character recognition. This enhanced optical character recognition need only one more step. You have to generate, oh, sorry, I put the wrong button. This enhanced optical character recognition needs generation of text areas. And now, if you want, you can start immediately the conversion and check what the enhanced optical character recognition is doing. Is now everything better or not? This is another stage. In this stage, we use another rules for optical character recognition. This is every time what you can do. And if you see that there's not a lot of differences, because here we are still not able to recognize this 111. Okay, you can do following. You can go here on optical character recognition and clean up it yourself. This is what we are doing every time before we convert. Like we generate the list of text areas, and then we look where our artificial intelligence suppose to be a text. And if our artificial intelligence is wrong, and this is not a text, we simply delete the text areas. This is everything what the artificial intelligence is supposed to be text. Now it is very fast done. You go here on delete, and you can, this is not text, not a text. This is not a text, not. Okay, and this is not a text too. Okay, very fast done too. This is not a text too. But this is only first stage. You will see later we will never recognize as a text. But what's happened here? I'll show you something. I deleted two, and this one too. Look what's happened. Normally, if you let this kind of text, you can do everything manually too. Like you can go here and take this is number area, and my number is going in this direction, and here's my number. On this kind, we are able to recognize text with every inclination. This is my number here. And if you tell us this is a number, we are more able to recognize the text because we know this is a number. Then we are looking for another, we use another rules. So like this is number and this is a number. You can reproduce here, so I can move it simply here. Okay, and here text area, we have a text. Okay, and this is very fast done, this correction of our text areas. It takes for huge scan, it takes no more than 10 minutes, but the quality of optical character recognition is now maybe 10 times better if you clean up it yourself. The quality will be 10 times better. Take 10 minutes and you have 10 times better quality of optical character recognition. Okay. Okay, I'm going here and look now how it looks in CAD. Open, let me check it now. Now it looks better. Okay, now we use here optical character recognition for the text with a spatial text area. See, this is the text. Now the text here is more better because we was able to recognize the text, and now look here, now we have a real text, and now this is not a text, this is a symbol. And this is what I recommend you if you have time for optical character recognition. Every time use this enhanced optical character recognition with generation of text areas and here you can start the video. You can see in this video how it's going. This is everything what I want to show you today in our webinar. Thank you very much, and bye-bye.